On our previous videos, we were able to pawn all targets under the child domain north.7kingdoms.local. During the process, we learned different Active Directory exploitation techniques. Aside from that, we learned different technologies and developed our own exploits to automate the foothold on the target. In this video, we will start attacking King's Landing to completely conquer the Iron Throne. Let's check if our target is alive. Okay, it's up. Although we already scanned the ports last time, let's do a quick scan again just to make sure most services are up. Okay, looking good as well. Port 80 is open. We should know by now that HTTP is one of the low-hanging fruits. This is unusual for a domain controller. Given that it's open on a domain controller, this makes it more attractive to attackers. So let's poke around. Let's open Firefox. Oh, it's a Jenkins instance. I have a good experience with this because, as you know, I'm a DevOps engineer. Jenkins was originally created as a build platform, but due to its popularity and wide range of customizations, it is now used for all sorts of crazy things. Based from the login page, this is one of the newer versions available. There is not much vulnerability and attack paths for Jenkins unless we are able to hijack a login credential. So let's try to hijack this login page. I always try to look for default credentials first because that is a low-hanging fruit. Let's try admin password. Didn't work. How about Jenkins password? Didn't work either. Remember, we have gathered some passwords from our previous targets? Let's try to reuse them. We only have a few, so let's just type manually. Trying Heart's Bane. Nope, pass 123. No luck either. How about I know nothing? Gotcha. This is a bad security practice. Domain credentials are being reused somewhere, so don't ever do this. Since Jenkins is essentially a build tool, it can execute command in the context of the user running it. So let's create a build job. We will use freestyle item since this is the most common and simplest form. Let's scroll down and add a build step that will execute Windows batch commands. Let's try a basic command to check current user privileges. Let's click build now and go to the build job to see the output. Do you see something suspicious? Account is running as system, which is the local admin on the box. Let's confirm by checking some of the privileges. The group membership doesn't look like it is an administrator. We should see a longer list than this. The privileges are also limited. I think it's because programs like this normally runs as a service account, which means some of the privileges are stripped out. Now that we can do a remote command execution, let's try to get a foothold via reverse shell. I'll go to my local directory containing the Nishang scripts. Let's make sure our HTTP web server is up and running. Let's find the invoke PowerShell TCP. Make sure it's added on the bottom of the script. I'll generate a base 64 encoded string for the command that will get the Nishang script in my Kali and execute it on the target. And lastly, let's make sure our Netcat listener is open. Before going further, let's explain the setup. First, we open up HTTP access to our local directory containing the Nishang scripts. Nishang is a collection of PowerShell scripts that is used for offensive security purposes. The script that we will use is invoke PowerShell TCP, which can do a reverse connection to our Netcat listener. In order for the target to get that script, we need to force it to run a PowerShell command having a base 64 encoded string as parameter. That base 64 encoded string is generated using this command. The first part is invoke expression commandlet, which will execute our Nishang script inside the target. Since Windows encoding is UTF-16LE, we need to use iconvene command to do the converted. Then the final part will be converting it to the base 64 encoded string. We do all this conversion so that our payload will not break due to unwanted characters. And finally, we need to prepare our Netcat listener to catch the reverse shell connection. Now let's put our PowerShell command on the build job and start the build again. The build is taking longer this time, which might mean it's launching some connection in the back end. And it failed. It says here the script is blocked by antivirus software. This indicates that Microsoft Defender is running inside the box. OffSec wants us to try harder, so let's try a few things. First, let's try a normal Netcat connection. We need to download a copy of Netcat executable inside the target, so I will serve it via HTTP as well. Then I will use certutil to download it to spool drivers directory, which is a common whitelisted path for App Locker. App Locker is another security mechanism which controls what applications and files a user can run. Then let's save the changes and trigger the build again. Something is still wrong. Our certutil command is blocked as well. Let's try now getting it via Samba share. I'll modify again the build command. I'll comment out the first command so we know what are the things we tried. Then I'll put the new command below. Let's try net use to access the Kali Samba share. Save again and build. Now it says it doesn't permit unauthenticated Samba access. So let's try to add credentials on our Kali Samba share. Same drill, modify the build job. I'll specify the user credentials on the Samba share. Save and build. Okay, it looks successful. Since the share is now mounted, we can now copy the netcat executable and run it. So let's do that. Our reverse shell is still being blocked. One last thing I want to try is running the netcat binary directly from the Samba share. It may work because I think the copy of netcat will stay in memory and will not touch the disk on the target. Now build one last time. Let's cross our fingers. We got a connection. But this is odd. We cannot see a command output. Let's double check our command. I think we forgot to use -E to specify the program we want to run. So let's try this. Now let's try running some commands.
Nice.
Now that our reverse shell is already working, let's look around. Let's check if our permissions is the same as we saw from Jenkins. They look the same. On our last video, we tackled this network group, which gives us permission to do remote lookup to Active Directory objects. So we should be able to query also the domain users. Let's try. Okay, there are a few users on the list. We need to take note of these names as this will help us carry out further attacks. What just happened? We got disconnected from our session. There is no error here. A Jenkins build job cannot run forever. At some point, it needs to terminate the job, get the exit status, and reports it back to the Jenkins master, which is the central part of Jenkins. So this is the reason why our reverse shell session got disconnected. Let's try to add a timeout on our build job. I'll choose the run with timeout build step. Settings like this typically disables the timeout when you leave it blank, so I leave it as it is. I'll just copy the command we have previously. Then I'll still use the execute Windows batch command. I'll save and build again the job. Oh, it failed. Let's see the logs. It returned a number format exception error, so it's obvious that we need to add a value on the timeout, so let's do that. I'll set the timeout for 2 hours or 120 minutes. Then let's try again. Okay, looking good so far. Let's explore the inside of the target. Oops, we are still being disconnected. This may be due to a global timeout setting in Jenkins which cannot be overwritten by individual timeout settings on each job. At this point, instead of playing around with the settings, I'll show you a more stable way of getting reverse shell connection. Jenkins allows you to execute Groovy scripts via the script console. This is an exploitable feature and must only be accessible to administrators. Let's try to access it. We can access it from /script. Let's go to the rev shells and generate a Groovy reverse shell. I'll search for Groovy. Change the IP. Specify our listener port. Lastly, let's don't forget to change the shell to a command prompt. I'll copy this and paste it on the script console. Let's fire up our netcat listener and run the script. This should give us now a stable shell without worrying about timeout issues. Now that we successfully gain a stable shell to the box, let's stop here and discuss some few important items before we end the video. In the earlier section, we were able to log into Jenkins via password reuse. But what if the passwords didn't work? We can use Metasploit to brute force our way in. Let's search for Jenkins. We are looking for an auxiliary module that will perform brute force attack on Jenkins login page. Let's try this module and display the available options. First, we need to specify our rhosts and rport, then followed by the user and password file. For simplicity, I will create a user file with one username inside it, which is Jenkins. But in real pen testing engagement, you will definitely need more than that. I'll also pick a common password file under seclist. Since this may take a while, I'm going to run this in the background. It's done, and it was able to find the correct credentials. And I forget to mention that I set the stop on success option to true. This is helpful in scenarios where you only have one username and you are running it on several passwords. So, as much as possible, try to eliminate the noise, as this will help you on OSCP exam by ensuring you don't miss any important details. Another thing I want to share is about Jenkins post-exploitation. Once you were able to log in, try also to check for usernames. Although you cannot decrypt the passwords, the list of usernames can give you advantage for password spraying attacks. You can also check the system logs, but I don't think there will be anything useful there. It is true that the default admin password can be seen on the logs, but initial setup requires you to change this. If there are projects and build jobs created, always check the settings. You might see confidential information such as secrets or hard-coded passwords on the list of commands. When I'm recording this video, I noticed there is no direct attack path for King's Landing, so I created a Jenkins instance to serve as the foothold path. Another reason why I chose Jenkins is that I heard some of the OSCP students encounter Jenkins on the Active Directory set, so this is a good opportunity to learn the basics. Installing Jenkins is straightforward. You need to install first Java since Jenkins run on a JVM. Then you create a service account for Jenkins. And lastly, install Jenkins, get the default password, and change it. But there is one small thing I changed, which probably very few will notice. When you create a Windows service account, default set of permissions are assigned to it. One of them is SeImpersonatePrivilege, but it is missing from the permissions we saw a while ago. So what just happened? Since we already tackled token exploitation on a previous video, I want to do something different this time, so I removed the privilege from Jenkins' service account. Removing it is a pain because I didn't see any options to do it, but I found a nice program that allows me to remove it easily. I used the SePriv program, which is a tool that can modify user privileges. First thing I did is to check the current privileges of local service account. We can see here the SeImpersonatePrivilege. This means any user you turn into a service account will inherit that. Then next is to remove that privilege. Nice and clear. It is gone now from the list of privileges. In order for that to take effect, we need to restart Jenkins service. You can use that tool to remove unnecessary privileges from a user in order to reduce the attack surface. Thanks again for joining me until the end of this video. I hope you learned the basics of Jenkins exploitation and different Active Directory topics such as Nishang framework and service accounts. See you on the next one.